Okay, well, I think with that, I think we should get started. If that's okay, Jacob. Thank you for hosting us. And again, thank you very much to altE for handling this great event for us over these several days. I think this is a week of a lot of good events, and the networking session will be, of course, later on today. So that'll be a good opportunity to get some FaceTime with everyone. Um, just to introduce myself, my name is Brad Burwald. I'm a senior product manager at Morningstar, and I think many of you probably know me and have seen me at many shows over the years. I've been with Morningstar for just shy of 20 years, so looking forward to talking about a variety of topics today, and also introduce Kyle Wilsey, who's joining us. Kyle, do you want to say a
Hey,
few
everybody.
things?
Sure. Yeah, I can't compete with 20 years, but going on 10 for me. I've been looking after a business with altE for almost that entire time. Miss being there in person in Devon. Maybe next year we'll get there, but appreciate the chance. I'll be kind of laying low here, taking on the Q&A. If we can't get to any of your questions during this session, we'll carry it over to the networking session. But certainly look forward to chatting with some of you afterwards.
Okay, thanks very much. All right, so I will go ahead and get started. So a little bit about the training today. As I've said, I've seen many of you have probably seen the description, and we're going to cover a variety of topics here and a little bit of some new information on some of the products. The first is the focus of the presentation really is about data, and that's not just about extracting CSV spreadsheets of numbers, so row after row, column after column. It's about looking at that data, especially with an off-grid slant, and understanding what's really happening with the system, how you can use that data and gain insights in the operation of your loads, the longevity of your site and its ability to maintain operation reliably over many years, the state of your batteries, of course, both lead acid as well as lithium, and really just understanding what's happening. And that requires some of our communication standards, and I'll be talking a little bit about that and how a lot of the products offer those features, and also what we're doing more in the future to address certain applications such as oil and gas and telecommunications. I'll be talking a little bit about our string sizer because it relates to that, and some recent changes and benefits that have been added to that, because that's also a very strong component of system sizing so that you can get the data that you want to see. And then also at the end, I'll be covering a little bit of info about some of our products that have gained some new certifications and listings. In just the last couple of years, well, Morningstar has always had a strong relationship with the national recognized testing laboratories, but even more recently, we've really had a strong emphasis by bringing additional in-house staff and working even closely with them to add additional requirements, UL, IEC, and several international standards. And just wanted to talk a little bit about those because Morningstar positions our products, as a premium product, hopefully best of breed. And with that comes, the industry compliance and testing, that kind of guarantees that. So we want to make sure to communicate that to everyone. Okay, so with that, I will go ahead and get started. And of course, a bit of a product overview is bundled in here as well. So what you need to collect this off-grid site data and use it to your benefit is kind of the topic today for off-grid system performance data. And what this really has to do with is, as I said, understanding the state of your system and how to get that data remotely. We've seen a lot of expansion in wireless and its use in remote off-grid systems, and that's really driving a lot of this as we're gaining 2, 3, and 4G connectivity, and 5G very soon around the world. So a little bit about Morningstar. We have over 4 million products installed in the field since our inception in 1993. And we've been selling in over 100 countries around the world for really mission critical applications. So we definitely are strong in residential and have some notable rural electrification projects, commercial systems, industrial, including telecom and oil and gas, as I mentioned earlier, is a big area of focus, as is security, also driven very much by the wireless connectivity options that we're getting. Also mobile and marine and even agricultural systems are among the many applications we serve. And we like to think of ourselves as the charging experts with a very broad and diverse product line, but also having very specific features for certain uses, which I'll talk about here shortly. And we're also proud to have the lowest hardware failure rate in the industry. And with so many units in the field and so many years of experience, we've actually got a lot of data showing exactly that we have a really reliable product, and our return rates are among the lowest in the industry because of that extensive amount of product that's in the field. So we can rely on that. Some of the core features of our products that really drive the technology behind the Morningstar difference is, of course, our power electronics design. So it's making the small, nuanced design choices in the products, at the circuit board level that really make them stand out in terms of processing capability, data, how we manage power electronics. For example, our multi-phase design, we never do just a single circuit. It's usually multiples, 2 or 3, sometimes working together. So we've got better efficiency, better reliability, and a lot of the design decisions we make at the circuit board level just to make the products extremely reliable. And we also want them to be easy to use. A lot of the products you'll see, the tried and true names such as Sunsaver and ProStar, are often on their second or even third generation of evolution, and we always make improvements, and we want a long product life cycle so that customers can kind of rely on these products year in and year out. So some of the questions I'd like to start with regarding real site data is, what are you looking to learn from the site? It's not just getting a battery voltage remotely or around the world using the internet. You want to really understand the state of health of a site. And if you look at a single site, what do you do when you need to manage many sites? And many can be dozens, 100, even 1,000 or more across an entire deployment, across a country or a certain region. How will I know that I'm at risk for having a load disconnect? Off-grid systems are about powering these loads autonomously. They've got to work year in and year out. We recently had a tsunami event just a couple weeks ago, and it reminded me of Morningstar's participation in a tsunami warning system that was deployed across many wireless sensors that are buoys that float up and down to see a tsunami as it's occurring far out into the ocean using satellite connectivity. And I always remember thinking, how do they keep tabs on these sites year after year to make sure that they're there, when you have these types of events, and that they're reliable and you can count on them, because they're not easily accessible in the middle of the ocean. So thinking about those types of deployments, and it also gives you a closer look at things like power production, how much you're generating, the battery charge behavior, is it properly cycling the battery? The load behavior, is your load a consistent draw, or is it something that turns on and off? And how do you measure, what that actually is in the real world? And then we can also incorporate that data into some of our improvements in how the strings are sized, whether it's more series or more parallel, and the types of modules you're using that, reap the biggest benefits from an MPPT controller. And we'll talk about that a little bit here in the future. So a lot of getting this data starts with accessing our data ecosystem. And this would be our products that are data enabled. They have communication ports, they have open protocols, and you can use our software, you can use our connectivity, or you can work with third-party sources to get this. And a lot of customers, OEMs specifically, even wire directly into our equipment to make our controller part of their product, and get the benefits of that data. So it really starts with, what products have these data enabled solutions. So I'll go through just a brief summary. I think many people are familiar with our products, so I don't want to give a detailed overview, but I'll just run through kind of our top of the line here. And all these products have, the connectivity that's discussed there at the bottom of the slide. So first, our Trisar MPPT and PWM controllers, really on the higher power range, parallel capable, and these are often used, sometimes many, for systems like on the right there, densely populated telecommunications towers that need a significant amount of solar array. So 3 kilowatts peak generally per controller. Oversizing of the array is a very common practice now, and something we addressed in our string sizer. So we see, just like with grid tie systems, even 4 kilowatts of PV put on a 3 kilowatt controller so that you get more consistent power output, through inclement weather or days when the insolation levels are not as strong. And this Tristar really covering 30, 45, and 60 amp power ratings, and is primarily a charger, and among the top of our line. The next is the Tristar 600 volt, similar power output capability, but with a 600 volt string input. And a good example of this system on the right there was a telecom site. And you'll notice almost completely vertical panels because of their location, with the sun being so low in the sky. And because of that, they had a great distance that had to be run with the PV, and therefore the high voltage PV input of 450 volts for the VMP was really beneficial because it kept the wire size down, saved them a lot of cost, and they were able to make these long wire runs from the array to the telecommunications site. Our ProStar MPPT and PWM solar controllers are really the product that got Morningstar going in the beginning, and this is now the third generation of each. And you'll see they've been added the capabilities of not only a lot of data communication, but also of a more powerful onboard meter display, so you can make battery refinements and access some of that saved data easily at the site. Okay, and that's actually a railroad installation there in the center of the screen. Our Sunsaver MPBT and PWM controllers, getting down to the lower power range, but also just as capable. And these products, definitely a favorite of oil and gas, which I'll speak to later, but also a big standard for any small industrial system because of their rugged design, their potting, encapsulation inside the circuit to make sure that they're very high temperature rated. And of course, also marine rated, because this is also one of the early popular choices in boating applications, in a lot of sailing and yacht applications where a Sunsaver was used to keep a battery charged up. In the case of the Sunsaver MPPT, just a few call outs here just to show some of the examples of the capabilities this product has. All our products generally are very high frequency design, meaning that we are measuring and analyzing current and making decisions in the product many times per second. In the case of MPPT controllers, we switch at a very high frequency, and that keeps the size very small, so it's very compact. We have all electronic protections, always rugged terminals, and we are definitely a big user of aluminum, often doing custom castings and extrusions so that we can have designs in the heat sinking that really gets the job done and allows us to meet our performance standards. And here's the example of the potting I talked about in our Sunsaver product. We seal the entire circuit inside of a somewhat flexible but still completely sealed resin that's inside the case, and then make sure that small components are not exposed to salt, air, humidity, extreme heat, and that's done a great job in making sure that the product can really achieve the longevity that we're going for. As I had mentioned earlier, we've been around since '93. A lot of the products really had a target of a 15-year design in terms of their life, and we've actually seen a lot of the products exceed that, and we've got the data to back it up because we have those installation records. And some products, even from our first generation, still in existence today in the field, sometimes in some pretty extreme locations, working day in and day out. So since the topic was some of the communications options, this is just a quick graph to show we have our standard proprietary RJ11 connection called Morningstar Meter Bus, and that allows some communication between the meter, and also can then be used to communicate with serial communications as well with various adapters that we make available. So for serial, RS-232, 45, which is an industrial multi-drop protocol often used throughout the industry, and then also Ethernet is finding its way on more and more of our products as standard, because whether it's wireless or satellite communications, or even some of these point-to-point radios that have grown in the wireless ISP market, packet-based data is really the easiest way to get information around the globe. So you'll find Ethernet on a lot of our products as well, and definitely an option on many of them. So with that, we support a variety of industry standard protocols, Modbus kind of being the standard, and what a lot of the Sunspec was derived around for inter-device control. And also we support SNMP, and this is a more recent addition in just the last couple of years to our communications options. But the reason we added this was because we found that with a lot of wireless communication and connectivity, that simple network management protocol was already being used by a lot of these customers already to collect data regarding the connectivity of their telecommunications equipment. So therefore, why not have the solar and power and battery data just right alongside that same standard protocol and be able to be connected and collected using the same systems that they were already using. So we wanted to make it easy for that industry or industries to adopt data with the Morningstar controllers, and we offered SNMP. So it's becoming a standard part of a lot of our products, and where it's not, it can be easily added using the EMC1 on all of our controllers that have that data port. So when you get, and getting back to kind of the system questions that we're looking to ask, when you get this data available to you, these spreadsheets or downloads or online graphs and charts that you're looking at, what types of things can you glean from that information? The first being, is the array, producing a consistent power? Is there anything wrong with the array, over the years? They have a very long life, but are you seeing any kinds of impacts such as shading that could be occurring? Trees that you grow and change over the years, and often a site that was ideal at one point in time may not be in the future. Often with the traffic industry, we see a lot of equipment that gets moved around to different locations. And yes, I'm sorry to say, we've even seen a few solar arrays set up on trailers under bridges, which is not ideal for a solar application, but it happens because it's a real world, and we've got, people trying to make use of the technology the best they can. We want to make sure there's no high voltage alarms. As you transition from summer to winter, you see different impacts on production. Low production during heat. In cold, you see higher voltages than you typically would see during the summer period. So is that, getting close to any kind of a high voltage that could cause damage to the system? Is there any current limiting occurring, meaning that, the array is tapped out or the solar controller is completely full, and maybe temperature is causing the current to be reduced? And lastly, one of the biggest questions we get regarding remote access for data for telecom, especially in parts of Africa, unfortunately, is my solar array still intact the way I left it? And are any of the modules missing? There's telltale signs of changes in the data profile that would indicate modules are possibly been stolen. It's unfortunate, but it's one of those real life conditions. In battery cycling, the questions you want to ask is in the case of lead acid, is that battery getting a full stated charge on a regular basis? A partial stated charge for lead that doesn't get to a full absorption stage is going to degrade over time. So you want to make sure it's sized correctly. And is charging current making up for what the load is taking out? It's a standard concept. The power that you take out, you want to make sure it's getting replaced, and that those are more or less in balance, or that you're generating more than you need for the system to be reliable. Is there any deep cycling risk, such as the battery being depleted to a damagingly low state of charge on a regular basis, which is going to mean that battery is not, going to have a long life, unfortunately. And also, what are the types of temperatures that the system's actually seeing, not just in the ambient air, but actually at the battery? Because as we are moving to a lithium storage future, we know that lithium has a few more limitations, a lot of benefits, but more limitations regarding low temperature charging. We're experiencing maybe, I think, 11 degrees last night, and I can actually see the change in my car charging profile. I have an electric vehicle, and I see the changes because you've got to heat that battery up before it can take charge, and then impacts charge rate. The same is going to, of course, be true with solar systems. So moving on to some graphical data here. This is sort of a perfect example of 3 days in the life of an off-grid system. And I know there's some very small text there, but you're basically seeing the array's open circuit voltage and VMP at the red and green at the top. You're seeing the battery, of course, at the bottom in blue, and you're seeing those current levels that are taking that into account. If you look at the graph there in the middle, you'll actually see kind of a perfect absorption stage. Peak current that gradually is reduced as the battery is reaching a full state of charge. So that's kind of what you want to see. And when you've got really granular data like this available, it's amazing what you can actually see at the site. It also tells me that on day 2, there was some very consistent sun, because the battery, did not, gain and lose its charging. It was just consistent throughout the day. On the 3rd day, you saw a lot of erratic behavior, probably a lot of clouds, and a PV array that was not really too stable. It still got the job done, but not as cleanly as the 2nd day. So this type of information is really useful, can be stored internally in the controller, as well as captured remotely over a data connection. And then a lot of our products just have a built-in web page, to serve up data using a phone browser or any type of device that can display an HTML page, can pull up this graphical data in a column format from within the controller or within our different data products. And you can see there a nice way to kind of see minimum voltage, maximum voltage, what's the average output of power, you get your temperatures, and also any faults or alarms are noted at the bottom there. So a lot of these tools are available to, get this kind of information. Here's a quick example of what I mentioned earlier, is making sure that your amp hours of charge are, adequate to make up for your amp hours of load that are going out. So that's a quick comparison. We're just a little shy there on a few days, which is not a big deal as long as you've got a fair amount of autonomy in the battery, but it is something to take note of. And over a longer period of time, several months, this is the first example of where you can start to glean a battery that is just starting to lose its life slowly. Batteries usually don't die instantaneously. They kind of just degrade, and then one day the floor drops out and you notice that your loads start failing on a regular basis. And you can anticipate that and see it coming if you know what to look for in the information in a lot of the data logging files. Okay. So another question then, besides battery performance and of course what your array is generating, is what are your loads actually doing? Now, in a residential application, you're living with a system, so you have the ability to turn loads on and off, and you can get data from your inverter, and if it's a grid connected system, you can change the behavior of your home and your loads and how much power you choose to use. But in an off-grid system, the way you set it up to work remotely is pretty much going to run autonomously. So whatever that load is that's being powered, it's going to pretty much need to stay on all the time. And it may have some fluctuations in power that it draws, but you won't really be there to have an impact on it or control it. But if you can capture data, looking at that after the fact helps you to better model your system designs, especially if you're going to repeat these systems in the future, and adapt to that. In talking with a lot of our customers who are system designers themselves, they said one of the big challenges is when they introduce a customer to off-grid, solar capability for some of their equipment, maybe from some traffic equipment, they find that often after the fact, the loads, after the system has been designed and sold and commissioned, that the loads increase. They get pretty happy with that free energy, and they might add additional equipment, and that may be okay, but oftentimes it can complicate the system design because they're no longer, they've changed the equation at that point, and it can pose some problems. And if the system is no longer performing correctly, that often is something that they look at is, have they seen a specific change in the load, meaning that the power draw was increased and the battery and the array may not be able to keep up with it. So some of the things to take into account with loads are, that a lot of them do not draw the same power over time. They may cycle on and off. They may vary in how much they draw. They may have an intermittent cycle. Obviously solar lighting is based on a schedule. We see a lot of equipment that runs on a, industrial process schedule that requires, say a pump to run, or other types of equipment that comes and goes. They may have a continuous power draw as they stay on, and then they might actually peak or spike in power that may not be accounted for, because depending on how often you log this data, you may not see those occurrences unless you're looking at it literally every few seconds. So keeping that in mind is extremely important. And then also the usage patterns of the user sometimes, can impact things. And if they understand, what it is they're connecting and how much it draws, many which do not, then it can actually help them to create better systems in the future. So here's just a quick example of some data that we'd graphed that looked at an overall draw. This is a process automation device at a site that was running through, it was actually a compressor station for natural gas. And it was really just capturing data, sensors, but there were occasional times when there is some valves being actuated, or possibly some injection pumps that are putting chemicals into a well. And over time, you see that it's got more draw during certain periods of time. But when you actually graph peak power versus average power, you'll see that there's significant spikes, and they don't run for extended periods of time, but knowing that they're there is really useful. And the only way to do that is, if you've got a really good amount of data being logged at the site. So when you're looking at those loads, these additional questions to ask about that is the load consuming what you designed for or what you expected? And when you inspect it, is it running more frequently than you realized? Depending on what's happening at the site. Are we seeing any outage periods? Are there any periods when the load is actually off? And that could be indicated by a fault, a load shutdown because of a short circuit. There's possibly damage to the load or a low battery. We do disconnect the loads during deep discharge of the battery. So if you're seeing low voltage disconnects during certain periods of time, for example, with solar lighting, from 4 to 6 a.m. when the load's been running all night, you might start to see some early disconnects. The sun hasn't risen yet, but the load has to get turned off early because it just doesn't have enough power to make it through the night. Those are early things that you can see to detect, when a system might need to be modified or when a battery needs to get replaced. Is the system able to recover that depleted energy with solar charging in order to keep, the battery out of those deep discharge states? You want to be hitting absorption, ideally at the very least every, I'd say 10 days. More often, like within the week, is really much better and much healthier if you want to see that kind of lifetime, especially out of lead acid. In the case of lithium, it's not hurt by partial state of charge much, but it's something you want to take into account. And it's also important not to look at a single day, but look at different points in time. There's some load cycles that are based on days of the week. They may behave differently during the weekdays versus the weekends. They may behave differently during the same point in time during one season versus another season, because it may run great in the summer. Systems often do, but in the wintertime, you're really asking a lot of that system. The batteries are stressed because of the cold temperatures. Their capacity is not the same. The array might be happy because of the cold weather, but because of the sun angle and the fact you can't adjust the tilt, it may not be producing quite the PV output that you expected. So checking that wintertime performance is also very important. And then lastly is your battery capacity adequately sized for a load. There are certain loads, pumps, large inverters, things that have a deep current draw. And when a battery begins to age, you'll find that those heavy current draws, they cause a significant amount of sag on a lead acid battery. One of the benefits of transitioning to lithium, is they can really provide a lot of current as a strong punch. So loads that typically were a lot heavier and harder on batteries, lithium is much more capable of handling that current. You just want to make sure you're using an off-grid rated lithium battery. But checking for those heavy loads is extremely important. Okay. So with that, those are kind of the questions, and that's really just to look at what can be learned from this data. And of course, Morningstar is here to support on a lot of these questions. And since we make this data available and we do trainings of this type quite often, we work with our customers a lot to get this information and to, of course, make it easier and easier to obtain going forward with the products. And you'll find with our future products, a lot more Ethernet integration, remote activity monitoring with wireless, even SD cards being integrated into our products so that you can get that data in greater capacity and it's more easily taken from the system and viewed offline. So next thing I want to talk a little bit about is with the discussion about lithium, our energy storage partner program is something I wanted to take quick note of because it kind of relates to a lot of this. What we found was that there was a lot of question, and obviously there's a lot of batteries on the market now. They're coming very quickly. I kind of see it as very similar to the big boost in solar module availability that hit the industry, say 15 years ago, where there's now many, many more options available, and keeping up with that is a challenge. So what we've done is created a partner program where Morningstar proactively works with engineers at those companies, along with our own applications engineering team, to make sure that those batteries are supported easily through standard presets and kind of pre-worked out configurations for Morningstar's product line that can be loaded very easily so that you've got that assurance that the battery is properly supported. And it really gives that peace of mind. Here's just a quick example. There's many more coming in the future of companies that we've worked with to provide support for both kind of a standard preset for both lithium and lead acid, to be honest, as well. And you can find a lot of that information on our website. And then loading it is a piece of cake. with our free MSU utility software and a variety of the data connection options that we make available. And you'll see long-term, as our products gain more presets built into the hardware, you can now load presets, using a lot of SD card capabilities on upcoming products. So it's going to get easier and easier as we go forward. And then one additional note on that is when we talk about these presets, that applies to all of Morningstar's products. And what we kind of call that as an open loop is just the charging preset, where we change the settings and we charge a lithium battery sort of the way we charge a lead acid battery with the right settings and accommodations made for it. But going forward, you'll see a lot more batteries have the additions of comms, where they have some communications and you may be able to get data out of that battery, but that the controller is still really just charging the battery posts using a preset profile. What you'll see on upcoming products is closed loop integration. And that would be where we actually have a communications link occurring between the controller and the battery, and where we actually are able to get feedback from the battery on what it wants to see, what its internal state of charge or temperature is determined to be. And we use that data in kind of a synchronized relationship so that we can charge that battery, with higher levels of current more accurately, and also use that state of charge data to make system sizing decisions. It's one thing to estimate state of charge from, shunts or other devices. It's another thing if the controller is able to actually ask the battery itself from its BMS, what its current state is. So we'll be supporting that more in the future. And that's generally done over, either RS-45 communications or more commonly CAN bus. So when you're looking at some of those battery information, here's some other things you want to take into account. First of all, the features and the intelligence of batteries are improving very much. I mean, they all generally have cell balancing and, kind of, both top and bottom balancing of the cells, and they have temperature monitoring, but they don't always have the ability to communicate that data. And what you're seeing is more and more, they do have the benefits of an open CAN link or even wireless connectivity, Bluetooth even in some of these batteries. We're also seeing of special note for off-grid markets such as ours and our customers, we're starting to see a little more lithium capability that has built-in heating built into the battery. And, that's going to be driven by the need for, off-grid sites in, the northern parts of the country, even in Canada, where you have sub-zero temperatures, and that lithium battery will need to, doesn't have to get warm, but it has to get at least to the point that it's not below freezing for it to actually receive charge. And that's really, as I said earlier, with electric vehicles, sort of the same kind of requirement. You've got to do that preheating capability of the battery before it can accept charge. And then from there, it kind of takes away from self-heating. So that's starting to become a part of batteries going forward, and we expect to see more of it as they're going to want to get into more off-grid markets. And the vehicle industry is driving that. And then as I mentioned earlier, then also the built-in communications interface, 45 for Modbus, CAN bus. We're seeing more and more standardization, which is a good thing, because the last thing anyone wants in a growing industry is a lot of product that can't talk to each other, and a lot of gateway and bridge communications. We want to get everything standardized. So that's definitely good to see. And we're seeing, more wireless come into the market as well. And many of this can be used for, getting system design data into it, completing a cycle count and understanding, how many times that device has been cycled, that battery, and therefore computing its lifetime. What is the temperature operating range that battery actually worked at? High heat degrades batteries, low temperatures inhibit charging, all that matters. And then also the peak current. You'll see a very dramatic difference in lithium batteries that are designed for kind of energy storage, grid arbitrage, and a very different set of specs for batteries that are designed for off-grid use or, high surge, and of course for the vehicle market. They can provide much higher levels of current and have to be designed as such because they handle very large instantaneous loads. So taking that into account in system design is important as well. So just to touch a little bit here on SNMP in more detail, this is another example of an open application where SNMP is used very widely, and that is the wireless ISP infrastructure. And you'll see that a lot of, especially this last year, during COVID. Unfortunately, that's a negative, but it's driven adoption and better connectivity for rural broadband for customers and a lot of times school children that didn't have access. So, those that have a gigabit fiber coming down our street in the suburbs are a bit spoiled, but there's still a lot of areas that don't have the connectivity. So wireless ISPs, 4G and 5G connectivity. Obviously, there's a lot of satellite connectivity options coming with Starlink and others. And that's been a boon for the industry and for people that live remotely who often want to use solar power as well. So there's some good things that are coming from that. And in supporting this industry, Morningstar added our SNMP data so that those customers, those IT, designers and engineers, and those already getting bandwidth data and uptime data from their switches and routers can now get solar data using that same protocol. It's what they know, it's what they like. Oftentimes they have very elaborate software set up for just this type of application. This is an example of one of our data partners, Zabbix, that actually makes SNMP monitoring software. It's in something called an NMS, a network management system. And we worked very closely with them to get the solar data integrated into their database and visualized, and most importantly, put right alongside the networking equipment. So that was a big success. And you can see some applications. I know the print's a bit small here, but it's a lot of data put into a timeline, time series data, when you can actually see, what the data was at a certain point in time at a given site. And it's all very easily organized, sometimes across hundreds of different systems. And they have some pretty good graphing capabilities as well built in. And most importantly, the ability to set alarms and notifications within the software so they can be told of when a site goes down or when a battery goes dead, and being informed by email, an administrative control panel, an SMS message, a push notification on their phone. They're quite adept at keeping on top of their networking system. Okay, so that's a little bit about SNMP data. Additional things I wanted to touch on, Morningstar string sizer goes right along with this, the sizing data that you've got to get your battery size correctly, but most importantly, your solar controller, you've got to make sure you've got the right array configuration. And we've done our best to continue to enhance the power capabilities of our controllers to increase the maximum voltage, as you can see with 120 volts on our ProStars, 150 on the TriStar, 600 volts, which is a bit unique in the industry with our TriStar MPPT 600. And you'll see that even our next round of products, those voltages continue to climb and those capacities continue to increase because modules are getting bigger, they're getting cheaper, and I don't think we'll ever satisfy anyone's hunger for power. So we're going to keep going in that direction. So with that, we always make updates to our string sizer on our website. We subscribe to a third-party database that's well organized and well groomed for accuracy, and it's just the only way to keep up with so many modules that are out there. So we brought in a lot of new module manufacturers. We've increased the total capacity of models in the database to over 50,000. We made a lot of software enhancements to accommodate first oversizing of the array. As I said earlier, it's now a very standard practice, even in off-grid, not just grid tie, for customers to put 20 or even 30% more wattage than the charge controller is capable of handling on that array, so that that controller is running, closer to full capacity more of the day, which just leads to better results in terms of autonomy and reliability. You're not selling that power, you're still charging a battery, and that's a finite amount of power you can put into that battery, but you know that you're going to more consistently get the power that you expected, even during off days such as during the winter. So and Morningstar always wants to really encourage that, because our products are designed to be oversized. They will not trip output current breakers. They will not allow voltage spikes to occur. They're very tight in how they control that power, and oversizing them. They're designed to work under continuous power ratings in those temperatures. So everything we've done on the design side is around fully utilizing 100% of that controller capacity. So we want you to take advantage of it, and now's the time. We're also, while they've been out for several years now, Halfcell Modules and some Halfcell Modules that are being cut and doubled have caused a few changes in how systems are designed, and we've taken that into account with our string sizer so that they can be adequately, sized. We've got to keep up with the changing trends in the modules, and these new kind of hotter cells that have a little more voltage than they did in the past, require a little bit of a tweak. So some examples here of when you get an output, say with the Trisar MPPT 60, you get in green the nominal configurations, as well as a few other configurations that may or may not work depending on your system expectations and your ratings of your specs. And what we do is we give a nice example of these different options on the screen where you can see, do I want to do 4,200 watts and oversize that system? What is moderate oversizing could be an option for you, and we give kind of guidance on these design choices because there are several that you can use. And then we give a nice color coding scheme here that gives you examples of when you're nearing a high voltage, when you're going to possibly see the controller current limit, during high power, peak power production, and also, when you can take advantage of MPPT power benefits, because obviously higher voltage arrays mean MPPT has more work that it can do, but it also yields a lot of benefits as well. So we want to give you good guidance on that. So just to talk a little more on the PERC and Halfcell modules, what you'll see is obviously higher efficiency, but also a little bit more voltage per cell. And we've seen a trend in that in order to pack more cells into a given frame, you're seeing a lot of cut cells come back into style again. They were really popular in the early days. In the early 2000s, cut cells were there regularly because there were a lot of demand for small modules, but now they're all so immense. What they're doing is they're actually doubling up the number of cells on the array, on the panel, and we've got to take that into account. The nice thing is it does give more power, more gains from MPPT, which is good news for us and for everyone, and also better performance in that if you have a partial shading impact of an array, it doesn't quite take the array out as dramatically as it did in the past. They're a little more resilient to partial shading. And here's some specs. You'll just see that the overall voltages on 36, 60, and 72 cell modules are a bit higher than they were before. And we've checked all the modules. We've looked at our product ratings and just made sure we're fully compatible going forward, and we are. Always a cautionary tale with 60 cell modules. They're always a bit of an oddball in terms of off-grid modules. You just want to make sure they're not ideal for PWM controllers, and they're still a little bit shy of a nominal 24-volt module. So we really recommend them more with PVT controllers, especially in series when that can be done. But always be careful when you're doing lower voltage 12 and 24-volt systems, especially if you're still using a PWM controller, just to make sure that the voltage is adequate. Okay, especially in high temperatures, because that's when they tend to go down in voltage and you can lose your charging capabilities. And we always provide a lot of guidance. You'll see a variety of white papers on Morningstar's website that talk about PERC cells, the impact on our designs, and what we're doing to keep up with the technology trends. And we give some quick guidance on how many modules you can use in series and in parallel for a given battery system. Okay, just a quick slide here that shows some examples of some of the products we talked about earlier. If you look in the center there, you can see the Trisar PPTs used in parallel. There's actually 8 of them, and that was used in a large telecommunications system. And we've worked very closely with, as I said, not only the wireless internet service providers, the WISPs, but also with a lot of large cellular or radio access network manufacturers as well. And Morningstar had been a participant in the telecom infra project, which is really paving the way for better and stronger open access, for 4G and 5G systems, not just for the wireless, but for the power systems as well. And we see a lot of hybrid systems being done, such as the one on the bottom right there. So it's an exciting time for sure. Okay, and then a last section that I did want to talk a little bit about here at the end is just an update on some new product changes that have occurred. And I know we serve a lot of markets. As I said, there's probably a strong presence of residential and homeowner applications, within this training this week. But also Morningstar does very well serve industrial applications. And we always want to make sure to mention that, because we do see a lot of designers that attend these events that may want updates on those products as well. So just a few brief slides here to talk a little bit about um, our continued path and strengthening ourselves for the oil and gas industry, which is a big user of solar applications. And solar is really been used in the industry, I think, even dating back to, if you can believe this, the late 70s, because of the remote nature and the fact that these are well-funded, very large companies, and they need to get data on from these sites remotely, because they've got very expensive assets, very important safety and process equipment taking place, and solar and these industries have always gone together extremely well. And when you're looking at gas and diesel generators, or even wind turbines, solar is a natural, very reliable partner of these industries, because of how hands-off it really is. So when you've got an oil pipeline, all you need is a 50-watt module, a Sunsaver, and a small sensor, to keep track of a very important asset in the middle of, sometimes parts of rural Texas, Mexico, and Canada, and other areas. So just to speak briefly to this industry, there are two areas that Morningstar participates in more, and that would be the upstream and midstream. In oil and gas lingo, this is basically your exploration and production, which is where it's coming out of the ground or being created. The midstream is actually the transportation of it, across pipelines and, consolidated with compressor stations so that it can be delivered, wholesale. And then, of course, the downstream is more the final distribution, where there's less solar used. But in these applications, there's a variety of uses for solar controllers. And here's just an example of several. And we support these applications every day, regarding remote terminal units, logic controllers, wireless, IO. There's a lot of temperature and pressure sensors, a lot of safety equipment, and then in some cases, emergency shutoffs, actual valves that can be turned off, with DC power in order to provide, safety shutdowns and things. And also the security market, the use of video cameras at these sites is also making a lot of gains because of 4G, allowing video to be sent wirelessly. And also, with artificial intelligence, there's a lot that a camera can actually see at a site. It doesn't have to be viewed by someone who's keeping tabs on things. It can see a fire, it can see a leak, it can see intrusion, it can see theft, all without supervision. So security cameras have gained a lot of capabilities within the space as well. And then in larger systems, Morningstar does a lot of cathodic protection, and this would be inhibiting corrosion of the actual pipeline itself, tanks, pipelines. If you put a kind of electrolysis effect in reverse to inhibit corrosion and rust with some DC power, you can extend the lifetime of a lot of this equipment for decades. Okay, and then of course backup power, big one as well. So just to kind of summarize our HAZLOC classifications, we do rate the products to basically not be a source of ignition at a site. And there's three ways to generally prevent a fire or an explosion. And that's to either isolate the explosive substance, which maybe always can't occur, especially if there's a leak. You can actually seal the equipment in an explosion-proof housing, which is extremely expensive, because you've got these really large bolted sealed enclosures that cost a lot of money. Or you can intrinsically rate the products for safety, and that's to make sure that a Sunsaver or any solar controller doesn't cause a spark or an ignition point, or have any kind of a high temperature device within its circuit under normal operation that could actually ignite gas. So we make sure that this is in place for a variety of our products. As I said, we've got in-house expertise from a lot of the labs that are on Morningstar staff, and our engineers work closely, as does product management and my team, working to make sure that we have these ratings for UL, for CSA for Canada, for IEC, for our international work, and also ATEX, specifically for the European Union. and we have to follow all this very closely. And all these products are marked specifically for these certifications. After a lengthy testing process, we're actually able to mark and list these products. So just like UL 1741 for home systems and for grid tie, we do the same for UL for HAZLOC systems. So it's pretty critical, and there's lots of fine details you can see on the right regarding the types of gas. But generally, what you want to take into account is these devices are rated to not cause an explosion during abnormal conditions. You know, they generally are not going to be inside of a explosive gas tank. They will be nearby that tank, and just designed that if there was a leak, that the controller and the solar system would not be a point of ignition. It's a standard practice, but it gives a lot of design certainty. So that is kind of a lot of the specifics of these tests. You know, there's it's called Class 1, Division 2, and the various groups of gases that could be included for anyone that would like to read the specific details. Okay, and there's all the certifications. But the bottom line is what the news that I really wanted to convey in this quick overview of HAZ location is that the Sunsaver product was kind of the Sunsaver and Sunkeeper were sort of the primary products used in that industry. And what we're pleased to announce is that the ProStar, both MPPT and PWM line, as well as the Sunsaver MPPT and PWM lines, have all had additional certifications put in place, so that you've got a lot of new opportunities for using these products. And here's kind of a short overview. So with UL and CSA, it was previously just 2 products. Now it's 5. And with IEC EX, explosion proof, and ATEX, those products were not previously rated at all for international use. And now the Sunsaver MPPT, and ProStar MPPT can be used internationally in, you know, around the world for these same types of applications. And why this is important is it's not just the rating, but also the fact that now MPPT can have greater adoption in these applications. Array oversizing, as I spoke about earlier, with MPPT can now be used, so you can more effectively use solar modules in these applications. There is a variety of lighting that's used for security and for, you know, work illumination at these sites. So we see a lot of HAZLOC lighting applications coming into play with these controllers that have built-in lighting control. And of course, the meter display. You know, the Sunsaver did not have a meter display, and now the metered products, you know, are allowed to offer that option as well. It's interesting, just a quick side story. We had to look at our products when a single button is pressed. What is the amount of energy on that meter screen that is discharged by that button? And we had to measure it and look at the temperature that it was caused and the amount of joules and the resistors that are involved in that design. That's the level of scrutiny that we had to review these products. A single button press, because you don't want that to, you know, cause a spark when there's human intervention. So it was quite interesting to go through this process, and we actually had to do an audit of our engineering process itself, you know, to make sure that this was all completed. So we're quite proud of that. And then a couple additional options. For the first time, communications. You know, the Sunsaver was one product at the very low power level that did not have data connectivity. But now with the Sunsaver MPPT and both versions of the ProStars, all of which are data enabled, we're seeing a lot of renewed interest in SCADA and communications links to these products now that they can be used in HAZLOC environments. And that's going to contribute very much to you know, better remote data logging. Luckily, the oil and gas industry and SCADA is designed around Modbus, which our products have used since their inception. So it's a natural fit. And just there's a rough idea of upcoming availability. Just a comment on the side there, like all manufacturers right now, it's a very challenging time in supply chain management and part sourcing for manufacturing, especially for silicon MOSFETs and microchips. So we will continue to do the best we can. And we have a very sophisticated team that is working very hard every day to manage this. You know, there are going to be hiccups. I think we're fielding it better than most, but do bear with us if you do see any product availability delays, because between international supply chain and our ports, it has been a challenge. But you know, we are working very hard every day. So to wrap up with Haslock, it's definitely the product of choice for these systems. It's also something to take note of, that these products are very well rated. So we like to think of them as top of the line in their class. So when you've got to have nothing but the best, definitely give these products a look, because even in applications where you're just doing something like a mobile or residential application, the Morningstar stands for quality over all these years, and the people that are here to support you will continue to do so going forward. So okay, that is the end of my presentation. So I think with that, Jacob, if you want to make any comments, but I think we're close to the top of the hour, and I'll be participating with Kyle in the networking event later this afternoon. So I'd love to get some FaceTime with anyone that would like to ask some questions.
Yeah, we don't have a lot of time now for an in-depth Q&A, but anything that did come in through the course of the session privately, we can address afterwards. Just maybe one or two, I think, kind of probably universally applicable questions. One is just that you'd mentioned, Brad, that in the future, as Morningstar's product development continues, that we might see SD cards, viewing data online, coming down the road. Can you comment on that just a little bit?
Yeah, I generally, more on onboard capacity, data logging, they don't want to just be measured in number of days, but how many data points per minute. And our kind of target going forward was years worth of data, and taking advantage of SD cards because of their cheap capacity, their low power, and the ability to, update firmware in the field or load new battery presets, such as the lithium ones I talked about, are all, very handy when they're SD enabled. So that's definitely a path that we're taking with the products going forward. Okay. And of course, remote connectivity as well. I think remote kind of trumps all, because nothing's better than sitting at your desk and monitoring your telecom site in Angola. But, SD cards do supplement that data option as well.
Yeah, a front mounted style SD card for, data storage, but also commissioning, I think is going to be pretty interesting. Should simplify, especially as you're discussing needing to configure batteries, configure controllers for lithium batteries, being sure that the configuration is exact and dialed in. I think that method of making sure that the configuration is consistent on an SD card loading to different controllers will be pretty interesting.
Yeah, there's a lot of variables, and being able to scroll down on that screen and saying, yes, I'd like to load, manufacturer preset, by model is extremely handy.
And that's a good segue. The next question was just around, what are the considerations, or what do I need to consider? What does one need to consider when looking at charging, again, closed loop, but charging the kilovolt battery line? What is it that Morningstar has provided in terms of interoperability or configurations to make that a little bit easier, take the guesswork out of it?
Yeah, well, when you get into a closed loop application, yeah, we have it even more. It's not just a preset, it's actually like a datacom profile to talk to those products. So when we have that coming with our what you've probably seen before in the past, our Ready Block interface, it's modular communications that can be added to our products that allow that CAN bus link or RS-45 link. And then when we connect with those batteries, it's not just a preset value, it's actually being able to talk to that battery and get its temperature readings, its state of charge, the amount of maximum current acceptance it would like. And that should be an even more out of the box level of compatibility. Very, very little configuration. Just choose the battery model, make sure that you've got a connected, data link, and you're pretty much done.
Okay. I know we're just about out of time here. Jacob, anything else you want to add to round out the session?
No, that was very informative. Thanks a lot.